We've been multiplying polynomials by a monomial, but today we want to take it to the next level. In this lesson, what we'll be able to do when we finish the lesson is we'll be able to multiply polynomials. It's a pretty simple process, and in fact, everything that we've already learned is all we need to do to multiply polynomials. We don't really need to learn any new information. Let's look at example 1. And this is the A portion of it. Write this down, please. X plus 5, parentheses, times X plus 2, close parentheses. So basically what's going on is now we're taking this binomial here, X plus 5, and we're multiplying it by the second binomial, X plus 2. So in order to do that, we're going to have to distribute or use the distributive property. Well, actually, in this case, we'll have to distribute twice. We'll see what that looks like here in just a second. And then once we do that, if possible, we want to combine any like terms. So let's talk about what I mean when I say we need to distribute. We'll take the first term of the first binomial, this x, and we're going to distribute it and multiply it by the first term of the second binomial and the second term, just like that. So we'll multiply x times x and then x times 2. We'll keep it as addition, and we'll look at what that looks like in a minute. Then we'll take the second term of the binomial, do the same thing. We'll distribute the 5 through. We'll multiply 5 times x and 5 times 2. So when I do that, we remember that if I don't write an exponent down, it's still there. And so this is x times x, or x to the first times x to the first. So I've got to add those two ones. It'll be x squared. Then I'll multiply x times the 2, and I'll get plus positive 2x. Same thing, taking the second term of the first binomial, 5 times x, so it'll be a positive 5x. And last, I'll multiply 5 times 2, and I'll get 10. So I'll have x squared plus 2x plus 5x plus 10. Now, remember, I want to look to see, are there any like terms? Do you see like terms there? Yeah, there are, aren't there? Right here's a like term, and here's a like term. So, and that'll typically be true. Now, not always, of course, but most often, especially if I'm multiplying two binomials, I'll have a set of like terms, usually the two middle ones. And even if I'm multiplying larger polynomials, there will be like terms to combine. So it's going to be x squared plus 2x plus 5x becomes plus 7x plus 10. And that's my final answer once multiplied. Let's look at a second example, the B portion of example 1. You write this down, please. 2x plus 4 times x plus 3. Really, I'm just using everything I've already learned. So I'm going to multiply 2x times x, so that's 2x squared. Then I'll multiply 2x times 3, that's plus 6x. Then 4 times x, so that's plus 4x. 4 times 3, which is 12. So I've distributed twice, distributed all the way through each term of the first binomial times everything in the second binomial. And I'm ready to look to see, are there like terms? And I can add the 4x and the 6x, so it's 2 x squared plus 10x plus 12. And that's my answer. Let me let you try one on your own without my help. So it's your turn. Write this one down. I'm going to label this one number 3 to match your textbook. X plus 1 times x minus 1. So what kind of answer you come up with that? So let's see what answer we've got. First of all, x times x is x squared. X times negative 1 is negative 1x. And 1 times x is another plus 1x, or x. I don't have to put the 1 in there, but I can. Positive 1 times negative 1 is minus 1. Am I done? No, I've got some like terms. What is negative 1x plus 1x? That's 0. So I can let those terms, they cancel each other out. They'll actually drop out, and my answer is x squared minus 1. Let's look at example 3a. In this example, we're going to take x plus 2 and multiply it times x squared minus 5x plus 4. There's nothing different here except now we're multiplying a binomial times a trinomial. So we'll distribute through 3 times when we use the first term and 3 times with the second term. So check it out. It's going to be x times x squared, which is x to the third. Then x times negative 5x, which would be negative 5x squared. And then x times 4, which will be 4x. All right, so we multiplied x times everything in the trinomial. We're going to do the same thing now with 2. So 2 times x would be plus 2x squared. Should have said 2 times x squared. 2 times x squared is 2x squared. Then 2 times negative 5x is negative 10x. And then 2 times 4 plus 8. Now, I'm not done because, again, I've got to inspect it for like terms. There's a like term. There's a like term. I see another one right here. Here's an x. Here's a negative 10x. All right, so I can put my like terms together. It's going to be x to the third. And I'm going to put x squared next because I put it in descending order of my degrees. So a negative 5x squared plus 2x squared is a negative 3x squared. Then positive 4x and a negative 10x would be a negative 6x. And lastly, there's nothing to combine with 8, so it's just plus 8. Questions on that? All right, let's look at another example similar to example 3a, example 3b. So write down 3x minus 4, and then negative 2x squared plus 5x minus 6. So let me let you try that one, okay? Go ahead and distribute 3x all the way through, and then the negative 4. We'll check your answer in a moment. So you've had a moment to work on that. Let's see what answer we got. First of all, we're going to take 3x and multiply it by negative 2x squared. So that's going to be a negative 6x cubed. Then 3x times 5x would be plus 15x squared. Then 3x times negative 6 would be negative 18x. Then negative 4 times negative 2 would be positive 8x, and that's positive 2 or negative 2x squared, so it's going to be positive 4x squared. And negative 4 times positive 5, negative 20x. And last, negative 4 times a negative 6, positive 24. We do have some like terms. 15x squared, 8x squared, and negative 18x and negative 20x. So if I put the like terms together, I'll get negative 6x cubed, and then I've got 15 and 8. What happens when I add 15 and 8? I'm going to get 23x squared. Then negative 18, negative 20 is negative 38x plus 24. My degree of my polynomial here, 3, 2, 1, 0. So I've got the degree descending based on the exponents of the variable. The answer is correct. Let me ask you a question. Is the product of two polynomials always another polynomial? In other words, when I multiply two polynomials, will I always get another polynomial? What do you think? Yeah, but by definition, it will be at least a monomial. So yes, and we're using the distributive property to multiply polynomials, so we'll have a polynomial answer. How about this? Can the distributive property be used to multiply two trinomials? Right now, all we've done is multiply a binomial times trinomial. And yeah, you're shaking your head. Yes, that is correct. You can use the distributive property no matter how large the polynomial. Look at number 9. I'll give you just a moment to try that one on your own. Let's check the answer. 3x times x to the third power will be 3x to the fourth power. Then 3x times 4x squared will be plus 12x cubed. Then 3x times negative 7, negative 21x. Then 1 times x cubed would be plus 1x cubed, or I'm just going to write as x cubed. 1 times 4x squared, 4x squared. In fact, when I'm multiplying times 1, life gets kind of easy. The last thing I want to do when I go to combine my like terms, and notice I've got a set here, and I've got that's it. It's the only two like terms I've got. I will need to write it in standard forms so that my degree is descending of each term. And so I've got a degree of 4, a degree of 3. Now this is a degree of 1, but over here is a degree of 2, so I'm going to need to put that in order. So I'm going to put 3x to the fourth power first. And then I've got 12x to the third plus 1x to the third. That's going to be plus 13x x to the third. Now, in my multiplication, I had negative 21x, but I want to put 4x squared next because that's the next highest degree. So it'll be plus 4x squared minus 21x, and my constant, which has a degree of 0 at the end, minus 7. So when I present my answer, I need to put it in that form so that it is my answer is in the standard form in descending order of the degree of each term. So all I have to do to multiply polynomials is use things I know, use the distributive property and distribute all the way through, and then combine like terms.